doubts in the last class? Anyone?
Shear stress and shear strain, sir.
Please loudly.
Sir, we saw about octahedral shear stress and shear strain, sir.
Yeah.
Then we saw about invariance of stress and strain. Then slip line theory, sir, field theory, sir. And then we saw about the forging process or classifications of forging process.
Yeah. Okay. Okay. So yesterday we talked about the octahedral shear stress and shear strain, right? Then also we correlate with the von Mises criteria when we talked about the slip line field theory, and also I gave some example when we have talked about the polycrystalline materials. Okay. Then later we have talked about the forging process. In forging process also we have talked three classification, if you remember. Okay, so one we have discussed about the manually or the the forging hammer. Then second one we have talked about the forging press, right? The equipment wise. And the second one we have talked about the with respect to the temperature. So one is cold forging, or the second one if we can classify like hot forging or the warm forging. That second part. And then the third part we have discussed about the in which the degree to which the flow of the work metal within the die, that also we have discussed. One is open die forging, then impression die forging, and the flashless forging. And the open die forging, you have the the lower die should be the stationary, and from the upper die with a certain velocity you are applying the force. But in case of impression die forging, you had some based on that die size, you can prepare your sample, or maybe you can do your forging process, but you are getting some flash in both the side, and that flash is not waste actually. So that one is the excess metal, you do not need that one, so you can remove that one. And the third one, you have the flashless forging. In the flashless forging, actually the die is of course is stationary, and with the help of a punch you have to forge it. Okay, but you will not find any flash there because this will be within that die, so you cannot find anything extra. And whatever the volume of the initial raw material you will find, and is equal to the volume of that the space, or maybe that volume of that die you will find. Okay, whatever the space is inside, so it will be almost close. So these are almost we have covered in the last class. Okay, so today we will talk about the open die forging, and based on this, few equations are there. Based on this, we will make two numerical, but the numerical is a little big, but not so difficult. So at least whenever I am teaching, you have to write very small equation, maybe 3 or 4 equations are there, very small. So you have to write it, and you have to also write, for example, there is equation epsilon, you can see in the slide, epsilon equal to ln h0 by h. So already this equation already we have talked in several times. So also at least write you can what is epsilon, what is h0 and h, so that when we will make some calculation, so it will be easy for you to put that value. Okay. So the simplest case of open die forging involves the compression of a work part of a cylindrical cross section between two flat dies, much in the manner of a compression test. So if you will see the schematic diagram here, so if you want to, last time what we have, I have given the schematic diagram of the open die forging. So if you have a sample here, okay, in between, so the height is, let's say you have h0, okay, and your this die, the bottom die is stationary, or this is fixed, and the upper die is moving, and you are applying a force with a certain velocity, and the diameter of this sample or this billet, let's say, and this is a d0. And the moment you are going to the second stage, so what will happen? So two things you will find. So initially when you are pressing, so the force is 0 because at the initial level. Okay, so at the initial level, when you are applying, so the force is 0, and the moment it is gradually increasing, then you have some force, right? So when you are going to the second stage, so that means in between what will happen? So in between when you are pressing or you are giving the force, so your height of this billet actually, or height of this sample is decreasing because you are already pressed. And the moment your height is decreasing, your diameter is increasing. Okay, because it is pressing. So the moment it will press, so it will be flat. Okay. And in the third case also, when you have to go to the final stage, according to your demand or whatever the whatever the customer's demand, so you have to go, and this height is decreasing up to HF. Okay, so that means from initial H0 to it is going to H, and again it is going to the HF, or the final height. or your diameter again, it will again increase from D0 to D and D to DF. And this is the simple sequence of the open die forging. Okay. So this equation you have to write here. Under this ideal condition, the true strain experienced by the work during the process can determined by epsilon equal to ln H0 divided by H. Okay, please write it. Okay. So where epsilon is, this is the true strain, and H0 is known as the starting height of the work. For example, this initial one, the starting height of the work, or maybe the workpiece. Whereas the small h is known as the height at some intermediate point. Okay, so that means whenever you are decreasing or whenever you are pressing at some intermediate point, so the height is considered as h. Okay, and unit is much more important, whether this is mm or cm, so you have to make it uniform. At the end of the compression stroke, h is equal to its final value hf, and the true strength reaches its maximum value. Okay, is it clear this slide?
Yes, sir.
Okay. Then the second slide, it shows that when you are calculating the force, because now, already we know the process actually. So in the process, we are giving some force, we have some velocity, and we have the height, and we have decreasing, or we are decreasing the height because we are pressing, then also the diameter is increasing. But how to calculate the force to perform, whatever the, the forging process what we are calculating, and the force required to continue the compression at any given height h during the process can be obtained by multiplying the corresponding cross-sectional area by the flow stress. Okay, so the F equal to whatever the flow stress you have, YF, because these are also we have discussed in the previous classes, YF into the cross-sectional area. So the force is calculated, or the force equal to the flow stress multiplied by the cross-sectional area, where F equal to the force, the unit also you have to think whether we are giving in pound or whether we are giving in Newton, and A equal to the cross-sectional area of the part, whether this is mm square or maybe inch square or maybe meter square, and YF known as the flow stress, whether this is in Pascal or megapascal or maybe pound for inch square, right? This equation also you have to write. Okay, and one more point also I will tell about here. If, for example, the flow stress is given, so also some of the equation we have studied in the past. Okay, so if the flow stress equal to K into epsilon to the power n, that equation also you have studied, so I didn't put here. Okay, so here also I mentioned the flow stress YF also increases as a result of work hardening, except when the metal is perfectly plastic. And in this case, the strain hardening exponent n equal to 0. So that means when we are talking about the YF equal to K epsilon to the power n, so that means also you have to consider that n. Okay, so this n is known as the strain hardening exponent n. Okay, so that equation also you have to remember, YF equal to K into epsilon to the power n. And what is K? Anyone?
So strength constant.
Strength coefficient. Okay.
Yes.
Okay, fine. Yeah. So here also you can see when we are talking about last time I put the cylindrical billet, but also at the same time, if you have a cylindrical billet also, so can, when we have the cylindrical work part. Okay, for example, this is not a rectangular work part. If this is cylindrical work part, also you can, when you will make it press, or when you are giving the force also, you are finding this kind of structure also. But whereas because we are thinking both the way, one is and the length or the diameter is, let's say, D0, and the diameter is changing to D and to DF. And similarly, the height is also decreasing from H0 to H and H to HF. Okay, and also one more thing here we have discussed what we talked before, that F equal to YF into A. But when we have some the shape factor, or when we are talking about some last time what we have discussed about YF equal to K into epsilon n. So when you have some shape factor, so similarly we can calculate this F equal to Kf into YF into A, where this Kf is known as the forging shape factor. Okay, where F and YF and A have the same definition as in the previous equation what we have discussed, and Kf is known as the forging shape factor. And this Kf is also defined as Kf equal to 1 plus 0.4 into mu into D divided by H, where mu is known as, because Kf already you know the forging shape factor, and the D already you know this is diameter of this billet or of this cylindrical work, and H you know this is the height of this sample, or the cylindrical work, and mu is known as the coefficient of friction. Okay, just you can write down these two equations, F equal to Kf YF into A, because earlier we have discussed about F equal to YF into A. So here only we are adding this forging shape factor. So F equal to Kf YF into A. But how to calculate the forging shape factor? The Kf equal to, because you have some friction also. So the Kf equal to 1 plus 0.4 mu into D divided by H, where mu is known as the coefficient of friction. Okay. Have you wrote?
Yes, sir.
All the students, please write the equation so that we will make two numerical, little big numerical. So you need some time. But if you know all the equations, so I think you can do it. Have you wrote all the students?
Yes, sir.
Yeah, okay, fine. So if you'll go to the example 1, yeah, just you can see here. Yeah, a cylindrical workpiece. Okay, so can you see the example in the bottom? So I just hide the answer part. Okay. A cylindrical workpiece is subjected to a cold offset forging operation. The starting piece is 75 mm in height and 50 mm in diameter. Okay, so when you will solve this problem, you do not write everything now, because we are doing in the class. But when you are writing in the exam, you have to write everything. Okay, so that means you have to write height equal to h equal to 75 mm. Diameter equal to d equal to 50 mm. You have to write like this, because I know what is d and I know what is h, but you have to write, okay, in the exam. But now you do not need to write. You just write h equal to, for example, 75 and d equal to 50. It is reduced in the operation to a height of 36 mm. So that means you are getting from 75 mm to 36 mm. The work material has a flow curve defined by K equal to 350 megapascal and N equal to 0.17. Assume a coefficient of friction of 0.1. Determine the force as the process begins. Okay, so that means the first question is asking, determine the force as the process begins. When the process begins, actually, at that time, how much force is there? Then second is at intermediate heights of 62 mm, 49 mm, and at the final height of 36 mm. Okay, just you can go for the first one. The determine the forces as the process begins. Then we will go for 62, 49, and 36. And if you will find only one, then others are same. Okay, so one at least try you can do, then you can go for the 62. So you can just write what are the given value, then what to find out, and all the equations you can write somewhere, so that it will be easy that which sequence you will go. So you have to find out F, right?
So KF is 1.06.
Kf equal to 1.06.
Yes, sir.
What is the equation you have taken?
1 plus 0.4 omega d by h. Mu d by h.
Yeah, so 1 plus 0.4 into mu is how much? 0.1.
Yes, sir.
And d is how much?
75.
D is
Sorry.
75.
Sorry, 50. Oh, okay. I did that wrong.
Yeah, D is 50. Yeah. Then H is 75.
So 1.026.
Yeah, fine. Yeah.
Yes, sir.
Then next, what is the next step?
We have to change the height.
No, because you need the f in the beginning. So why will change the height? Second step we have not gone because you need, Nihar told that he found out shape factor kf, but you have to find out force, not the shape factor is the one step, but you have to find out f.
Yes,
Right,
sir.
this one, yeah. So f equal to what is the equation?
K by P.
Yeah, so kf already you got. So now you have to find out what is yf and what is a. Then only we'll calculate f.
So can you please show the formula for YF?
1 second. So the flow stress, na? So this is k epsilon to the power n. Otherwise, I have to go back because it was in module 2, I think, right? Okay, 1 second, I will open. Module 2. This one, na? Can you see the screen?
Yes, sir.
Yeah,
Yes.
k epsilon to the power n. Okay. Yeah, this one you can see. Maybe one more. I think we have in pictorial also. I have some. Yeah, this one here.
Okay, sir.
Okay.
Yes.
So all the students, please write this equation: yf equal to k epsilon to the power n. This equation you need.
So
Okay.
divided by 1 plus n, right?
Divided by
1 plus n.
y.
There was one formula which says 1 plus divided by 1 plus n.
Oh, we learned here somewhere.
Yes, sir. Yes, sir. In this module itself.
But that is not necessary, no? Because they need only yf.
Okay, sir.
Okay, so you can go because k value is given.
Yes, sir.
What is k value?
So 350, I guess.
Yeah, 350 megapascal. So if you have k value is there, n value is also given. And epsilon is, I think epsilon value is not there, right?
Sir, it's ln h by h I.
But you do not have one value, na? Because it is asking in the beginning. So you cannot go for another height now.
So the intermediate heights are given also.
But the question is, the 1 second. The question, sorry. The second one is intermediate height, but the first one is determine the force as the process begins. When the process begins, you have to calculate there. So if epsilon is not there, okay, so you have to assume. Okay, but where is epsilon is there, then you can take it. But now for the the first question, we have not gone for at intermediate height now. Just only we are calculating determine the force as the process begins only. Then the
Okay.
second question, determine the force at the intermediate height of 62. Then the third question is determine at the intermediate heights of 49. Then at the final stage. Okay. So the moment the epsilon is not given, then you have to assume. Okay, so you have to assume the approximate yield point of the metal. Approximate yield point. So what is the approximate yield point of the metal? The strain. Anybody know? 0.002. Okay, so you can consider epsilon as 0.002. So that means you have to calculate YF equal to 350 into 0.002 to the power 0.17. Are you getting?
Yes, sir. 121.6.
1 second. 121.6.
68.
68. Yeah. What is the unit? Your unit also you have to tell. This is flow stress, YF. So what should be the unit? And 350 is given in megapascal. So unit will be in megapascal, right?
Yes, sir.
Yeah. Okay. Vishnu, are you getting?
Yes, sir.
Okay. Other student, only 3 students are responding. Harsha, Surya, Anirudh, you are silent this time. Aditya, please do it because a little, not so difficult, but only you have to go in a flow, maybe 4 or 5 small equation you need, not a very big equation. Yeah, so you got YF equal to 121.68 megapascal, right? So that means when F equal to KF YF into A, so KF already you have calculated 1.027. YF already you have calculated 121.68. Then you have to calculate A. So how to calculate A? You have all the value. So cylindrical sample. So A equal to pi d square by 4, right?
Okay, yes, sir.
Yeah. Okay. So you can calculate how much is A. Is it difficult? Small equations only, not so very big like integration derivative. Yeah, Anirudh, you are telling something. Yeah.
Sir, Nihar here. Sir, F
Yeah,
is
yeah.
24.
How much Nihar A?
A is 1963.49. F is 245,302.7.
A equal to 1963.5. Yeah.
Yes, sir. F
Mm
is,
square. Square.
yeah, and F is 245,302.7.
What is force?
Yes, sir. F.
Yeah. What is the unit? So Nihar, you are missing the unit every time. Your calculation is fine. Your process is also good, but you are missing the unit. Okay, so unit you should not miss. So every
Is it
time do
kilonewton?
not forget. Yeah, Achutan.
Is it kilonewton, sir?
Kilonewton or only Newton? Only Newton, I think.
Oh, 1 minute, sir. I'll check
Yeah,
and let
just
you
you
know.
can check. I think Newton probably. If kilonewton, maybe it will be 245 point something. Yeah, whatever Nihar is telling, this
I
probably
think
it will. Yeah,
he told 245 only, no, sir.
245 kilonewton. Yeah, fine.
Okay.
Yeah, you can make it like whether this is kilonewton or Newton. This is not an issue, but you have to tell the unit. Okay, so if you will miss the unit, then at least you will get some less mark or less point. Okay. Okay, then again you can go for the second part. So first part is clear. So now you have to determine the force at the intermediate height 62 mm. Okay, the second, do not go for 49 and 36. Maybe not required now. If you can calculate the intermediate height of 62, then you can calculate 49 and 36. Okay, just you can go for the intermediate height of 62. Others you will calculate at home. Okay, in the similar way. So now epsilon you cannot take 0.002. Vishnu, you cannot take epsilon 0.002. Whatever the equation you were telling at that time, that equation you have to go because it is going to intermediate. So that means you have initial height, then again you have the decreased height. Amal, are you getting?
Yes, sir.
Yeah.
Yes.
Okay. Okay.
Is it 531.65 kilonewtons, sir?
Oh, already you calculated F equal to
531.65 kilonewtons.
no. I think it shows 649 kilonewton. How much is epsilon?
It's 0.19, sir.
0.19. Yeah, this is correct. Then YF?
263.91.
Yeah, megapascal, right? Yeah, this is good.
Yes, sir.
Then you have then you have to calculate area, right?
Area will differ or it will be same, sir?
No, area will differ, na? Because it changed, na? So initially
yes,
it was,
yes.
yeah, so it changed. So other student, are you getting epsilon equal to 0.1904?
Yes, sir.
Yeah.
Getting.
Okay.
Yes.
So then flow stress, how much? YF equal to?
Sir, 263.9.
Yeah, megapascal. Yeah. So up
Yes,
to
sir.
now that is clear. So now you have to find out F. Okay. So for F, you need again, you need KF and again you need D because there is no D. Okay. So because height is given, intermediate height of 62, but you need D diameter because it is pressed. Initial diameter was given 75. Sorry, 50 mm. But now the next diameter or the when you have pressed, so the second diameter you have to find out. So for diameter, find out how we will go. So if you have area or maybe if you have volume, then only you can find out D. Are you getting?
Yes, sir.
Okay. So a little, when you will read the question carefully, then you will, find what are the given value. And if you will write the final equation, for example, F equal to this equation, then you will find this equation, this point I need or this, point I need or this point I need. Then only you have to go step by step. So how much is A area? Have you calculated? Because area you cannot calculate it directly because you do not have D, right? Nihar?
Yes, sir. I'm trying that area.
So you can calculate volume. So if you calculate volume, initial one, because in volume, this D, initial D you can calculate because the initial volume. Then you have to go for the area. Or maybe from that volume you can calculate the area, then you can calculate the diameter. This is the best way. Otherwise you cannot calculate. Because the sample is same. So that means the initial diameter is same. So you can calculate the volume of the workpiece, total volume. So from that total volume, you can find out the area because you have the height, 62. Okay, then you can calculate the diameter.
Fine, sir.
Yeah. So you can go the initial volume and then go for the area. Then because if you have volume, then divided by the height, so you will find the area. Then you can go for the diameter from the area, pi d square by 4.
Sir, is the diameter close to 55 sir?
55, yeah, true. How you calculated? You calculated volume?
Yes, sir. I calculated volume and changed the height.
Yeah, it's done fine. So volume you calculated, then from volume you have the height. So you calculate the area, then from area you calculate the D. Yes, only calculate F, then you will find out the force.
Okay.
Other, if you can calculate the third part and fourth part, you can do in the similar way. Okay, so there is not difference. Only the first part and second part both are different. So that's why we are calculating 2. Then third and fourth you can do at home. Okay, just you can try because you need a practice. If you need practice, you can do it in the exam immediately because you have only 15 to 20 minutes for each question. Okay, otherwise it will take a lot of time.
Sir, what's the new diameter?
55 mm.
Okay, sir.
Okay, maybe I will show this because you have done lot. Just you can see. Okay, so the first part, I think it is clear because you have YF K into epsilon to the power n. So you have K is given 350 into 0.002 because we have taken the assume the strain of 0.002 because this is because the epsilon is not given. So this approximate yield point of the metal we have taken. So we got YF equal to 121 megapascal. Okay, so the Kf equal to the equation whatever you have given. So if you will use all the the terms, then you will find Kf equal to 1.027. So F equal to, you can calculate with the help of that equation, you will find 245 kilonewton. Okay, and the second part, it is asking at intermediate height of 62. Okay, so when you are calculating the intermediate height, so the diameter is not same because you have already pressed. So the moment you have pressed, your diameter is increased. Okay, so that means you will, if you will find less than 50, then this is wrong. So that means you have to find increased height because you have already pressed. Height is decreased from 75 to 62. Okay, so that means your diameter will increase from 50 to something. So the epsilon equal to ln the initial height divided by the intermediate height. So 75 by 62. So you will get 0.1904. You will not assume here because why we have assumed in the beginning, because you do not have the strain there, because it was asking determine the force as the process begins in the immediate when it started. In that time it is asking what is the force. Okay, and then we have calculated YF with the help of that equation. You will get 264 megapascal. Okay, so now to get the value of Kf, you need the D value. Okay, that is important. So D we do not have because initially the diameter was 50 mm, but after pressing, now we have to find out what is the diameter. Okay, so area also you cannot find because you need D, pi d square by 4. So you have to go for the volume because the initial volume and the final volume there is no difference. So initial volume, if you take here the workpiece volume in the first line, okay, V equal to 75, whatever the the starting height into pi into 50 square divided by 4. So you will get 147 262 mm3. So if you have the volume and your intermediate height is given 62, so you can find out the A, the area. And the moment you have calculated A, then you can find out D. So D is 55. So this is justified because initial height, initial diameter was 50. Now it is increased to 55, right? Then Kf you will get 1.035. Are you getting K equal to 1.035?
Yes, sir.
Yes, sir.
Yeah. So then F with the same equation, you will get 649 kilonewton. Okay.
Sir,
And
could you just tell again, like, how did we get 0.002? Was it just an assumption?
yeah, 0.0 initial, na? Initial because the strain rate was not given initially. So we have assumed that the strain rate is 0.002. So I have written here why we have assumed, because if this is not given, so we have taken the approximate yield point of the metal, approximate.
Okay,
Okay.
sir.
So
So
just
if
we have
any
assumed that.
question comes like this, should we take the like this if the strain is
Yeah,
there?
you can take as 0.002. If it is given, for example, if it is given, maybe in the next question we will do. If it is given, then you do not need to assume. Okay. Okay.
Yes, sir.
And
Yes,
at
sir.
home, you can calculate the third and fourth part. If this is intermediate height of 49 mm and the final height of 36. So you will just write somewhere F equal to 955 kilonewton and F equal to 1467 kilonewton. Just you can do at home. Okay, in the similar way. Whatever the second part you have done, in the similar way, third and fourth part you can do. Okay.
Yes, sir.
Okay. So we have one more question. So just you can go through a little fast. Maybe we have only 10-15 minutes. Yeah. Yeah. So a cylindrical part is worm offset force in an open die. The initial diameter is 45 mm and the initial height is 40 mm. Okay, so initial diameter is given 45 mm and the initial height is given 40 mm. The height after forging is 25 mm. The coefficient of friction at the die work interface is 0.2. The yield strength of the work material is 285 megapascal and its flow curve is defined by a strength coefficient of 600 megapascal and strain hardening exponent is 0.12. Determine the force in the operation just as the yield point is reached, yield at strain 0.002. If this is given, okay, so just go for the first part. Do not go for the second part now. So you have to find out the force when your yield point is reached at the strain rate of 0.002. So you can write the given, just the, for example, h0 equal to this one, h equal to this one, d equal to this one. You can just write in this way, but in exam you have to write everything clearly. Initial height h0, final height hf, diameter of this, the cylindrical sample d, capital D equal to this much. You have to write. Okay. So again, in the similar way, you have to find out, kf. Also, you have to find out a, then volume, then h. Here h is important, okay, because you have yield strength or maybe the strain rate. So if you have strain rate, then you have to find out. Sorry, if you have strain rate, then you have to find out the intermediate height. Okay, so intermediate height is not given.
Sir, intermediate height is given. Diameter we have to find.
Intermediate diameter, where it is given?
Height is given.
Height is given, diameter is to be found out.
No, this is true, but this is in the second part. Because it is asking just as the yield point is reached, Okay, so that means you have to find out when epsilon equal to ln h0 by h, epsilon is given 0.002. Okay, h0 is given, but you have to calculate h. This, the height after forging, you are talking about 25 mm, not that is, because when yield strain is 0.002, you are not finding that height.
Okay, sir.
Okay, because yield point is, that means initial force. When you have yield strength 0.002, that means this is initial force. That means you are just applied there. Yeah, first time what we have done, why we assume that one? Because we do not have that a force there. Just initially we have applied the force. So yield strength is that one. Okay.
Yes, sir.
Yes, I got it.
Yeah. So h equal to maybe very close to how much h is given. H is given initial height 40 mm. So when you have yield strength 0.002, I think you will find very close to 40. Very close. So YF you can calculate fast, then you can go for the H. So in exam, you have to study or you have to read the question twice or thrice, write the given, then write what you have to find out, and then go step by step.
Sir, should we have to find the intermediate height, sir?
Yeah. This is not actually intermediate height. This is only the h you can, because we have not forced actually.
No, sir. Should we have to find? I'm asking, sir,
Yeah,
because
you
we've
have
got
to, because
epsilon.
if you take h equal to 40, this is correct. But if you have in the question yield at strain is given yield strain 0.002, then you have to find the h again.
Oh, okay.
Okay, so h I think you will get how much somebody calculated h.
Sir, it's close to 39.92.
Yeah. So that's why, because if you'll take 40, this is correct. I do not have any problem. But if you will calculate the accurate one, then this is fine, because this is given yield at strain 0.002. So your h will be 39.92.
Okay, sir.
Okay, so then you can calculate your YF, then A, KF, what volume if you need, because you need a diameter, or diameter is given. Diameter is given, so you do not need to calculate D. Okay, so KF you can go, then F you can go. Area you need, you need area. Area is not given. So then you need to find out volume. So you have to little practice. Maybe that, third part and fourth part you can practice at home, so that it will be easy for you. Or if you have any doubt also, you can ask me next class, not an issue. So can I, have you done? Okay, you can see. So the epsilon is given 0.002. Okay, so YF you can calculate. Okay, so with this equation, so you do not have any question, because all the values are given. So you will find 284. Okay, so your epsilon is given 0.002. H0 is also given, initial height 40. So you will find H equal to 39.92, what you have already done. Okay, so then if you want to find out A, so before that A, you have to find out V, volume. Okay, so volume is pi d square H by 4. So D is given, H is given. So you can find out the volume, initial one. Okay, so do not take this H value, initial H value. Okay, do not take 39.92, because the volume is same. So you can take the initial H. Okay, so you will find out V equal to 63,617 mm3. So if you have V, then you can take area. How much is area? So in this H, actually, you have to take this 39.92, because this is the final H, after the initial force you have applied. So then you will find A equal to 1594 mm square. Okay, so do not take H value equal to 40. Initially volume you have to take H value 40, but this final H value you have to take here 39.92. Okay, because this is after this trend. This is not before this trend, after this trend. Then KF, all the values are now here. So KF you can find out 1.09. So if you have KF, then F equal to, you have YF into KF into A. So you will get 494 400 Newton, or maybe 494 kilonewton. Okay. Are you getting the first part?
Yes, sir.
Yeah. And the second
Yes,
part,
sir.
just I'm telling, maybe you can, what we have discussed in the previous question, the similar we can do. The second part, it is given at a height of 35 mm, at a height. Okay, so when 35 is given now here, so you have to find out epsilon equal to ln 45 35. So epsilon will be changed. Not epsilon is 0.002. This was at the initial stage. So now epsilon you will find different value, 0.1335. Okay, then YF you can calculate, then volume also, the whatever, the initial volume is same when you have the second one. So volume is remain same. So you can calculate now A equal to this one, then you will calculate F. Okay, in the similar way. Now, if first part is clear, then second part, what we have done in the previous numerical, in the similar way we can do. Okay, and the third and fourth part you can do in a similar way, like 30 mm and 25 mm. Maybe you can do at home. Just you can try. If you have any question, you can ask me in the next class. Friday we have. Okay, and we have a meeting. Probably I will talk about the question, what are the questions actually from module